Okay, so this is our second runner architecture discussion, but this is the first one that has a topic. Last week or last month, we just talked about what this meeting should be. So I'll quickly restate. It's just a chance for us to discuss something that is cross-cutting across the runners, architecture changes, kind of a deeper conversation about a technical topic. It's not necessarily a learning session, so it's not curated content in that way, and it's more open-ended, but it is meant to be focused. So we've taken a poll on Slack last week, and we want to talk about the internal autoscaler, executor provider, and the instance executor, and how these things relate to each other. So yeah, I asked if anybody wanted to kind of like introduce the changes. I could do it. I don't feel I'm necessarily the best person to do it, but I can take a crack at it. And then we can discuss. Any questions before we get started about like what this is, what we're gonna do, etc.? No? Okay. All right. So let me give this my best representation, and Tomasz, feel free to jump in and tell me if I get anything wrong. Okay, so here's the deal. Auto scaling was kind of a feature of a specific executor, which was the Docker machine executor. Okay. We wanted to replace Docker machine, but we also wanted to add auto scaling to other executors. It didn't really make a lot of sense to sort of have it, coupled to that. So there was a change made by Aaron to create this internal executor. So if you look at GitLab Runner, under executors, there's an internal folder, and inside internal, there's one folder called autoscaling, or I think it's just autoscaler. And it is an executor and executor provider in that it implements the interface, but it's actually a wrapper. So the idea is you take something else that you want to run, an executor, and you wrap it in this auto scaling executor, and it uses a library called Taskscaler to do the actual auto scaling. I can't remember exactly the structure of the code because it's been a little bit since I looked at it, and it's also changed since I looked at it. So trace through it and see if you can follow along. I gave a kind of a summary of it in the Taskscaler 101 video, so that might be worth looking at if you want like a more in-depth just like walkthrough of how it interacts. The code may have changed a little bit, but the concept is the same. Like taking, you take this, executor provider, wrap it in the auto scaling thing, which is driven by Taskscaler. So when you actually prepare it, it goes and it uses some cloud provider to get a VM or an environment. And it does auto scaling as part of this. Like it either creates it on demand or pulls it from the idle pool, and it creates these environments, gives it back, connects into there, and then actually uses the underlying executor to run the job. So that's the story behind internal autoscaler. The instance executor is meant to represent an executor when you just have control over a whole instance. I don't really actually fully understand this one, other than this is what we're actually using as the underlying executor for our new auto scaling scenario. So in your config YAML, you can provide an executor, but the auto scaling configuration is separate. So you should be able to apply auto scaling to any executor. So for our current fleeting Taskscaler setup, we use the instance executor, and we provide an auto scaling configuration which points to a plugin. So any questions about that so far? Or I didn't go into any of the plugin stuff yet, but I don't know if that's part of the question, part of the scope.
I have an observation maybe. So I did watch your videos, and at that time I also looked at the code, and that was
Yeah.
like a month and a half ago, so I don't remember much. But I got the impression then, and I get it again, that maybe there seem I get the impression that there's more abstractions and levels of indirection that are strictly necessary because we're trying to bolt on a new concept to the existing runner, or like
Yeah.
the existing interfaces of the runner and the runner provider. Does that match up with your understanding of what's actually there, or am I getting the wrong impression?
I get that impression too. I get that impression too. Um, from what I've read, you know, like my take on it has been that this is we're trying to do this in smaller incremental steps, you know, without rewriting the runner. Like, for example, we've discussed rewriting the runner and injecting the part that drives the workflow into the environment itself. I think Aaron called that task runner, which is a great idea. I think we should definitely do it, but it means rewriting everything right now. So yeah, I just haven't seen a way that we can like bolt it on or like wire it in there in a reasonable amount of time without all these layers of abstraction. But
All right, yeah. So
yeah.
yes, it's maybe the right impression, but there's a good reason for it, which is iterating.
Yeah. Well, the good reason is I didn't see a better way. So that's kind of like an absence of it's like the least worst reason, right? Yeah. So I mean, if you still feel like there's a way we can sort of pull out some of those layers of abstraction, or if there's a better way, do look into it and see if you know, it's not set in stone. There's nothing fundamental that makes all of these layers necessary. Um, it's kind of um, the heritage of the runner. Yeah. Yeah, you see that a lot, you know, with the back and forth and so the way that we inject functions into in like we have this structure which is the build, right? And it's kind of just a data structure, but in one place we put like a function, you know, to like actually do the thing. So you know, like we do this in a number of different places, like when task scaler brings up a VM, we have a hook to run some function to determine if it's viable or not, or if it's ready. Okay. And so runner, all the way back in runner, it injects a function that checks the nesting to see if it's up and running. It actually tries to connect to the VM and initialize the nesting server. So like there's this sort of like, you know, all the way back in runner, it kind of knows about nested virtualization. And task scaler doesn't, which is a little bit weird because it's kind of, I feel like runner should just know, just give me a place to run it. I don't care if it's nested 0 to 10 times, right? But it kind of does. So, but I didn't see a better way to do it.
Maybe I will jump here.
Okay. Tomasz, I can't hear you.
How about now? Okay.
Yeah, I can hear you now.
This whole work started with two big reasons behind it. First one is something that we are tracking since few years is to move out of using Docker machine, because Docker machine is our current way how we are doing autoscaling. It's not supported. It doesn't exist in fact as an official product because Docker just abandoned it. And we still depend one of our biggest feature on top of that. We need to move off it. The second thing is our Mac runners that we want to move from Mac Stadium to AWS. For Mac Stadium, we used custom executor and the driver that we call Autoscaler to, like, this was a kind of idea how we could move off Docker machine in the past. and we already know that it doesn't work well. It doesn't work in the way that we would like to. And these are two big things that we need to provide. And there are two ways that we can go. We can either redesign how runner is created, maybe change a lot of the abstractions that we have there, and fit new autoscaling method, whatever it will be, into that. Or we can fit the new autoscaling method into abstractions that we already have in the runner. The first one would be the best one, but it would take probably months, maybe even more, to do it in a good way, and we would still need to support the old version of the runner for some time, because like people will not migrate from one version to another in 1 or 2 releases. So we decided to do it gradually in smaller steps, just like Joe said. So we are bringing new autoscaling methods, we are bringing new tooling for autoscaling, but we are injecting it into the existing abstractions that we have in the runner, and we don't want to make it like we don't want to repeat the mistake, or hard to say the mistake, like something that we did with Docker Machine is that we strictly tied autoscaling with specific executor. You can't get the autoscaling that we have in Docker Machine executor and start using it, for example, for the shell executor, because Docker Machine executor is what's making the autoscaling. And because we have these few abstractions like executor interface, executor provider interface, the way how we use the build object to create some scripts and then send them to the execution environment for running the job, we are using all of these abstractions to bring the new autoscaling mechanism. And one thing is what Joe said is the internal package, internal autoscaler, which is built on top of executor provider. And this is something that brings us autoscaling abilities. It allows us to dynamically request a new place for a job to be executed. And Joe in a moment will talk about the plugin system that we have there, how we are making it possible for users to implement support for different cloud providers. This is happening in the Autoscaler. It works on the level of executor provider interface. So when we want to start a job, from the configuration file, we get what executor provider is configured for that runner. We go to that executor provider and say, hey, do I have a place for that? And if yes, give me a place to execute a job. Executor provider does the magic and ends with an executor interface implementation object that we can use to run the job. The second interface is this executor interface. So a single object that has everything needed to execute a job in some way. In this case, this is this new instance executor, which uses all of the information that were provided by this new autoscaling mechanism to call the target environment. Because for now we are talking about cloud provider and VMs, but there are ideas that we can have something like local provider, which means that we are locally connecting to some shell, or we are connecting to an external VM through SSH or through WinRM in case of Windows machines. The result is that we have an external shell on which we can execute jobs. With that, the instance executor that we already have in the runner is able to replace the shell executor when we will get the local provider, is able to replace SSH executor if we will provide it a static credentials for a specific host to connect. We could replace with that parallels and VirtualBox executors by just providing a plugin for Parallels and VirtualBox. And at this moment, we have plugins for AWS and for Google Cloud Compute, which means that we can request dynamically a virtual machine in Google Cloud or in the AWS, get SSH or WinRM credentials for that, and run job there as it would be a shell executor. The next step that is already planned but not scheduled yet is injecting that into Docker executor, which would be in fact replacement of the Docker machine. So with this, we are using the same executor provider, which is the internal Autoscaler, which has the same way of configuration of autoscaling, connecting to cloud providers, the same set of plugins that allow us to use different providers or local one or static external VM. But then we will be using the information that we get back to configure Docker executor to use Docker engine on that external machine, which is what Docker machine does for now, right now. But we are then using the same mechanism to have both shell and containerized version of the executor that is autoscale.
Yeah, I think we're taking a practical route here, so I think it's also important to make sure we know what our North Star goal is, like what the architecture is that we want, because then we can seize opportunities to go in that direction. So this is a good opportunity to discuss that. I think Tomasz hit on something really important, which is, simplifying the number of executors. So in the notes, I linked a blueprint, which I created mostly to capture other people's ideas about deprecating some of the executors that are like redundant in a way, so that's part of our North Star, is to sort of like have a more simple orthogonal set of configuration between executors and autoscaling, etc. Yeah, any questions about that before we go into the details of the plugin system? Cool. First of all, do you want to learn about the plugin system? Is this something you want to discuss? Okay, cool. Because it's wasn't explicitly stated in the poll. Okay, so the other half of Docker machine is n different providers, like there's big cloud providers, there's small cloud providers, there's everything in between, and this is a case where we don't really want to couple with them all. And when I say coupling, I mean like, number one, importing all of their code, right? You probably can't get AWS, Azure, and GCP's Golang dependency graphs to mesh perfectly, right? Why would you even try that? It's exceedingly painful. I know, I've tried it. This is one of the reasons why, we shell out to, Docker machines. It's kind of nice, you can treat it at a distance. The other part of coupling is not just the code, but also the configuration and the details of these machines. Because, every cloud provider has a slightly different way of describing and abstracting the environment. And there's a bazillion different ways you can, so many different machine types and memory and networking, and, etc. So the approach that we've taken in this next pass on generic cloud providers is, first of all, treat them as an opaque, homogeneous collection of VMs, an instance group. And that's what it's called in this package called fleeting. So fleeting is used to provide this abstraction over instances. So there's an instance group, and now you just turn the dial, more or fewer. And you can request access to one of them with some details, and you can delete one of them. Just what you need to control capacity, to consume capacity. And so Task-Scaler uses this interface. So the Task-Scaler itself doesn't have any idea what kind of VMs it's using. It just uses this interface. Runner also doesn't really know, like it just kind of provides an implementation to Task-Scaler. but it's a specific implementation which is built as a separate binary. This mechanism for managing binaries is HashiCorp's Go plugin. And I think HashiCorp originally created this library when Golang's plugin system didn't exist. But Go does have a plugin system, but it's still not sufficient for our needs because you have to have a perfectly matching dependency graph. So we still use this HashiCorp Go. It has the additional benefit of it uses or can use a gRPC mechanism under the hood. So we can think about it when we're thinking about the interface backwards compatibility. We can think about it as a service interface, put on our service hats and be like, okay, here's a new optional parameter. Some clients are not going to have it, some will, figure out how to version it. We know how to do that with Proto and everything. On the flip side, it does a really nice job of taking all that complexity and hiding it behind the interface. So you take the Proto, you actually have a client and a server, but those are like Go shims, if you will. And then you just use it as an interface, kind of the way you do with a regular gRPC client. So runner's job is to start one of these binaries, set up the plugin and inject it into Autoscaler. So it says, hey, here is your fleeting provider. And so in the auto scaling configuration now is a binary name. And these binaries, like they really are a separate file. So we're going to have to figure out how to distribute them and version them, etc. That's some of the work that's part of this change. But the advantage is we will have a very decoupled architecture in that we're going to every cloud provider will have its own repository, which implements this logic. And some of them we will probably own and curate because we have a vested interest in running on all the major providers. So we'll probably run those. But there's nothing preventing someone from creating a new provider. We're happy to host the code and let other people contribute to it, but they could even like build their own as a separate binary because all they have to do is import the interface, so they know what to run, and they can inject it. Like there's no change necessary to runner, so it's fully decoupled. So this will help us scale our contribution as well, hopefully. One of the challenges is people are using Docker machine and they have a problem and they want to fix it, or they have a new machine type and they want to use it. But nobody's helping with Docker machine. It's just us. So they're blocked on us. There's a human bottleneck, which is as unpleasant as it sounds. Yeah. So anyway, so yeah, these plugins, they just basically provide this. They actually provide two interfaces. They provide like the instance group and a connector, which gives you the underlying connection details. SSHing basically into the VM.
I think one of the things we talked about before, though, Joe, is that one downside, though, is that troubleshooting is going to be more difficult when we have
it's in a separate binary. So if your preferred method of troubleshooting is running delve and stepping through the code, you're going to hit a boundary there. You can still use printf debugging because when the plugin starts, it uses standard in and standard out as part of the protocol, but it does create another set of sockets and routes standard in and standard out output from the plugin through those, so you can do what you want with it on the client side or on the runner or Autoscaler side. So when you print something, when you go like printf in the plugin, it still pops out on the console, which is nice. So
I think I also
definitely.
Sorry, go ahead.
No, go ahead.
I was going to say I did see as well that someone out there had said there's a way to build breakpoints into the binary that Delph pick up on, but I haven't tested that myself. So
Yeah, that's like next level stuff, man. I'm sure, like somebody will figure it out. I'm at the stage where like I need a really simple recipe for like how to drop in the debugger. What I remember is like, you say go run, right? Go run dot run. And then if you want to debug it, you just say delve debug, and you add 2 dashes after the dot, and then you're in there. So that's a simple transformation for me, but like I haven't delved into debugging plugins that way. I know. Yeah. So there's definitely things that makes more complicated. Like we've spent a bunch of time on life cycle of these. I just approved something that will give you a warning if you just hit Control C on the runner. It'll shut down uncleanly and leave the runner or the fleeting plugin running in the background. So you got to make sure you kill those. But it should give you a warning now. It properly was Tomasz added all the wiring required to properly shut down if you give it a sync quit. So it should be okay. But it's more complexity. Anyway, so that's the plugin mechanism. It's pretty cool. It's actually not super complicated when it comes down to it. These plugins are really simple. Yeah. Any other questions or concerns around this?
I have one.
Go ahead.
Yeah. So I'm wondering, are we planning to have like a plugin for Kubernetes or those kinds of things, or it's just for now to replace like Parallel, VM, VirtualBox, SSH, and those executors?
Yeah, that's a great question. And we've kind of had some discussions around this in particular about which executors should we keep. The way that I'm thinking about it right now, and again, this is not like anything set in stone. Kubernetes is already an abstraction over the architecture, right? Like it literally could be Minikube on your machine. It could be a cluster. It could be the desktop next to you on your desk, right? You have no idea. So it already sufficiently like abstracts what's in there. And it's a whole, like, it's an ecosystem like that's kind of its own thing. Like it's a first class member, right, of Runner. Like we really want to use it more. So I feel like it makes sense to keep a Kubernetes executor and to not do any plugging, like really the plugin mechanism. It's an alternative to Kubernetes because Kubernetes already has the cluster autoscaler that's going to give you VMs. So it lives alongside the Kubernetes integration. Yeah. Does anyone disagree with that approach or have anything else to?
Thank you.
Yeah. I think there's if you take a step back and think about all the possible like dimensions here, there are some interesting use cases we haven't explored yet. Like what if you had a local plugin that just executes on the box where you're at right now, hard coded, or stuff like that. Like there is like a testing plugin that we use for integration tests, or we will use. So those are worth thinking about as well.
I think for development, it sounds like it'd be super useful to have a local plugin.
Yeah, definitely. I'm a big proponent of making the local development experience a first class like citizen. I know that GitLab is very CI first focused, and but I would really like to make sure that you could do everything you need to do locally. There are some places where we come short, like if I see a failure in CI, I can't always reproduce it because the expansion of YAML includes happens on the server side. And I don't really know exactly, like, I can't do it. And we're deprecating the, GLab exec or runner, the exec command or whatever. So
Yeah, like local plugin is not related to that, in fact, because like you can
yeah,
still
I was talking about the
you
whole like local development
like
experience and the whole scope of the things that we do. Yeah,
you can
that's a good.
you can still want to have this local experience of execution, like
Mhm.
read a better version of GitLab runner exec, but use new autoscaling with, for example, Google
Mhm.
Cloud or AWS or something else, or Kubernetes executor, just to see if your configuration that you want to put on your machines is the correct ones. The local provider here, local plugin, is more about being using a local shell, a local host to execute jobs instead of using a cloud, in fact. So exactly a replacement for the shell executor that we have right now, but not a dedicated executor, but the same code, the same mechanism that we'll be using for the rest. There are two things I wanted to add to this talk about plugins. First one is that as per latest decisions of our product, the plugins that we will own is GCE, AWS, and Azure. We are already working on GCE and AWS for mostly AWS right now for the macOS runners. GCE will need to be polished when we'll be working on Docker machine replacement, because the next dogfooding will be replacing our own runner managers that we use for Linux from Docker machine to this new mechanism. And Azure is something that is not developed yet. It's scheduled for the future, but these three are the ones that we will own, maintain, make all of the decisions in. And then whatever else the community wants to support will be open to the community. And like Joe said, we can create a good place for that. We can interact with some community members, give them some maintenance on the projects, but we will be not doing any strict maintaining on that. There should be no expectation that we will be providing any fixes or changes in the other plugins. It will be open to the community, so you can bring whatever you want, but you also need to be responsible for that and to maintain it for the future. The second thing, and this probably also will reduce a little confusion around what we can put into that plugin system, is that this whole plugin system is built around concept of maintaining instances. And in difference to Docker machine, with the new plugin system, we don't want to control every aspect of the instance. We want to use concept of instances groups, autoscaling groups, however it's named in the cloud provider. Most of the cloud providers provide something like that. So for example, currently with our Docker machine executor, when you want to autoscale on, let's say, AWS, you need to fill a lot of details of the machines into runner configuration. What machine type you want to use, what disk type, how big disk, how much memory. Basically, any new setting that is added to the cloud, we need to map in the runner. Any setting that is changed or removed, we need to update in the runner. Otherwise, it will not work. With the new concept, we are just saying that we want to create n instances or delete n instances in the instance group named my group something something. And then it's an external responsibility to configure that group so that it provides you VMs in the form that you want. But then, as this happens in the cloud that you want to use, this cloud already provides you tools and understanding of how to make that. It's up to date with what should be done. We are just working on the concept of creating new instances, deleting some instances, and tracking what instances we have in this specified auto-scaling group. And this is how the interface of the plugin is built, so that we don't need to interact directly with how every VM in every cloud provider is configured. And then still, if the cloud will not provide concept of instances groups, the plugin should be still able to do that like manually, because the configuration that we have in the runner is just marshaled into a JSON and sent to the plugin. So for most of for the 3 providers we want to have, we will be working in this auto-scaling group concept. But if you want to provide a plugin for your exotic cloud provider that you're the only user of, and you can just set 3 options of the instance and this is all of the API, the plugin should be able to do that. And we just transfer all of the configuration details that you would like to have.
Yeah, that's a really good point about that escape hatch of like, you can actually do whatever you want inside the plugin, even provide your own instance group implementation. And your point that like the part that you put in the plugin configuration in the YAML all the way in the runner doesn't get validated. It just gets packaged and shipped right through to the plugin. So it's like pass through. So whatever configuration you want to put there is what the plugin gets. So you don't have to, we won't have to couple with details of every plugin. So thanks, Tomasz. Those are really good. Those are really good additional points.
Going back to Kubernetes, given how complicated Kubernetes is to configure and deploy, and how relatively simple this sounds like it'll be, do you guys anticipate that it will eat away at Kubernetes usage? Or does Kubernetes have something else to offer that this new approach doesn't offer, that would keep people using Kubernetes?
Tomasz, it looks like you wanted to say something on it first.
Yeah, like setting up Docker machine for Linux is already easier to work with Kubernetes executor on Linux, and we still have a lot of users using Kubernetes, which means that there is something they just want to have. Maybe it's because they feeling better to use Kubernetes. Maybe it's because they have some requirements from compliance, security, government, or any other factors that just require people to use Kubernetes. Maybe it's because in Kubernetes you can add many things around. Like we, from the runner side, we are maintaining pods with some containers, but then you can connect many other things that there are in Kubernetes: secrets, volumes, different services, and you can work inside Kubernetes. So you can start a job in Kubernetes, and then this job has access to everything that you would have by deploying something to that Kubernetes cluster. So depending on your policies, you can use that to maintain other applications that you have on your Kubernetes cluster, for example. So there are many reasons why people are using Kubernetes executor right now, even if it's not the easiest one to use and not the best experience, because it's still, like, if you compare it to the Docker one or the Shell one, it still looks a little less mature, and people want it. People want it, and they don't want to move to Docker machine. They don't want to move to anything else. So I think with this new auto-scaling for Shell and for Docker, I don't think this will get a market of Kubernetes executor. It's rather a replacement for any other that we have, and a new addition. Like with that and Docker machine replacement finished, we can finally have a Docker machine version for Windows, which we didn't have, never. But for Kubernetes,
I agree completely. I think that in this case, for this fleeting plugin mechanism, we've created something very simple and easy to use. It's very nice, but for a very narrow problem set. Kubernetes, on the other hand, has taken all the things that you do with infrastructure and applied a uniform abstraction to them. So you can understand the pattern, you know it's the same throughout, and there's so much tooling now integrating with it, that it's just the standardization alone, and the layering alone is a reason to suffer a little bit, you know, and use things on Kubernetes. It's worth it. So yeah, like Tomasz said, the Kubernetes, like the more we can do to make the Kubernetes experience seamless, the better. And this is for all the other stuff that the people want to do. So yeah, totally. You know, there's some interesting things we could do with regard to Kubernetes, like we have this configuration in our YAML that is getting a little bit more declarative about what you want, rather than like, you know, rather than just saying this executor with these details, you know, we're breaking it out a little bit more. We have more details in the auto scaling section, for example. It's possible that some of those auto scaling details could be used to inform the way that we use Kubernetes. For example, having some additional capacity reserved for runner jobs. There was some thread about this not too long ago, where we were discussing like what does it mean to have idle capacity in Kubernetes? And while, you know, like the cluster autoscaler is a little bit remote, you know, you can actually reserve capacity for yourself by creating preemptible pods, and scaling that. So it is actually relatively simple to implement some of those auto scaling parameters in Kubernetes. The implementation is going to be radically different, and it may be a lot harder because we're trying to use Kubernetes for batch workflows, which is not the first use case that it was built for. So it's a little bit less mature. But there are some features, you know, like for example, you know, we're starting to get the ability to control which pods are deleted when you scale down a deployment, you know. But in our case, you know, we're using jobs anyway. So yeah, so Kubernetes is definitely, I think, going to be in the long term, a first-class citizen of the runner.
Here to stay.
Yeah, get used to it. Add a K to your middle name. I don't know. I'm a big fan of the abstraction and value that Kubernetes provides. It makes a lot easier for me to move between the layers and reason about like how the system should come together. So, yeah, I don't know very much about our agent though. What's that agent thing that we inject called? There's a word for it. The thing that installs runner for you.
Helm chart.
Okay, Helm chart.
No, there's the Helm chart, and then there's the
operator.
Operator. Thank you.
Yeah.
Operator. Yeah. I read a discussion. There's an issue like what do we do with Helm chart versus operator? And I think that they're going in the direction of doing the operator first, because the operator then, you know, turns around and uses the Helm chart. So anyway.
Helm charts are painful. Operator is because it's basically a templating system that allows you to automate some of the deployment specification, but then you need to implement all of the logic in templating language, which is not very good experience. With operator, you just create a binary. You just create any complicated logic that you want, and it uses API directly to create your deployments, manage them. So it's like really working with software and not just templating some of YAML files that just doesn't work well with more complicated scenarios.
Yeah. So yeah, I feel like we've kind of really covered our intended topic.
Yeah.
Anything else you want to discuss, or should we just close there?
No,
That
but
was useful. I found it useful.
thank you. Yeah. Thank you for taking time to explain everything.
Yeah. And of course, it's still a moving target. I think the concepts are going to be stable, but like hopefully we can continue evolving the code and maybe even removing a few layers of abstraction, as we move along. Cool. All right. So I'll stop the recording and end the meeting. Thanks.
Thank you.